This combination of reagents carries out the acid-catalyzed addition of an alcohol across the alkene. In this case, it's going to add an H and an OR, specifically an OCH3 in this case. It's Markovnikov addition. That way the H ends up on the less substituted side, the OCH3 will end up on the more substituted side. One thing we do have to be careful of, though, is that our intermediate is indeed a carbocation, and so rearrangements are possible. If we take a look at the reaction, in the first step, you actually add the H on the less substituted side. That way you get the more substituted, more stable carbocation. This is a secondary carbocation. The two adjacent carbons would be primary, so they're not any more stable. This carbocation, therefore, is not going to rearrange. And ultimately, where the carbocation is, that's ultimately, in the end, where the OCH3 ends up. So again, we added that H to the less substituted side. So if we take a look at those two carbons where we added something, this carbon right here is not a chiral center, does not have 4 different groups, and neither does this one, having 2 identical methyls on these sides. Since we didn't form any chiral centers, we get a single achiral product as the correct answer, and there indeed is your correct answer.